Look at doing the uniform motion problems. These are the ones that it's a lot easier if you use a chart. If you can do it without one, that's fine. But I think the chart's preferable. It is based on the formula D equals R times rate times time. So this is distance, and this is rate, and this is time. Okay, the big thing in college algebra, when you get to more advanced problems, and this is what you got to watch for, is you got to make sure your units match. Your units match. Okay. This is, we'll get to that in just a second. Let's go and get over here. And it says, we'll read it first. A man leaves home driving at the rate of 50 miles an hour. When his daughter discovers that he's forgotten his wallet, and she drives after him at the rate of 65 miles an hour. So how long will it take her to catch her dad if he has had a 15-minute head start? Well, we're going to take our formula. We are going to turn it around and make it rate times time equals distance. Same thing, just a different formation. We've got the dad. We've got the daughter. Okay, you are told some things specifically in the problem. Now, I will make a note. These boxes right here, these are filled with info that is either directly given or implied from the word problem. Okay, that is not the same over here. These are filled by multiplying the first two columns. So you're actually multiplying, doing the formula, rate times time, and filling in distance. Okay, so if it says anything about distance in the problem, don't touch it. We'll get to it later. Okay. What you are specifically told is dad is going 50, and let's just put this so we can see it, miles per hour. Daughter is going 65 miles per hour. Okay. The only thing that's told about time is things that you're going to have to infer. You just know that he's been on the road 15 minutes longer than her. But she's been on the road the shortest amount of time. So if I were you, I would come in for the daughter and put X because she's been on the road the shortest amount. Now this is where it gets sticky, and we've got to do this right here. We've got to watch our units because it's very tempting to say X plus 15 and put it in this box right here. But if you think about what this means, we are using the units of miles per hour. So we need to use the portion of an hour that he's been gone. So if you think about it, the 15 minutes, that's 15 minutes of an hour. That is 1/4 of an hour. So I really need X plus 1/4. Okay. So if I go through and multiply, because I've got to use my little note right here, I'm going to multiply these two things to get that. So I got 50 times X plus 1/4. And then I got 65 times X. Now you got to figure out what to do with these two distances. And every problem is different. You're going to have to think through it, visualize, and see what's happening. On this one, they left the same place. Dad cuts out, and he's going. Well, she tries to catch him. And the question is, how long does it take for her to catch him? Well, that means their distances are the same. Excuse me. So you got 65x equals 50 times x plus 1/4. Okay. So this is a little different, and I realize we did it this way in class. Shame on me. I need to go back and do it this way because we erred and used the 15. So we're going to go through here, and we're going to do 65x, and that will be 50x. Now we need to know what 50 times 1/4 is. Guys, all that is 50 divided by 4. So 50 divided by 4 is 12.5. And it's not going to hurt a thing to put 12.5 there. It's a terminating decimal. If it didn't terminate, we'd go fraction. Okay, so subtract your 50. I've got 15x right there, and I got 12.5 right here. So I'm going to divide both sides by 15. So x is, now I need to reduce that because you can't have a decimal inside of a fraction. So I need to do 12.5 divided by 15. And you remember the magic buttons I told you? Second, PRB, enter. And then second, ABC, enter. You need the last part if it's improper. This one's not, so it didn't really change. So it's 5/6. That means 5/6 of an hour. Okay? 5/6 of an hour, if you think about it, so 5/6 times 60 minutes, that is 50 minutes, which is the answer that we got the other day. But 50 minutes is what it takes. It doesn't matter which answer you give me. They're both the same unit of time. But please be careful with the units that you're using. You know, you need to know, are you telling me hours or are you telling me minutes? So, just for the sake of discussion, I will do another one on that. Excuse me. So let's make a chart here. I'll tell you what, I don't think this one's a good one. Let's go to the next one. Here we go. Okay. Reality TV show, officer traveling a police cruiser at 90 miles an hour pursues Jennifer, who has a 3-minute head start. If the officer overtakes Jennifer in 12 minutes, how fast is Jennifer traveling? Okay. Same setup. So we got the police, and we've got Jennifer. And we're going to have rate times time equals distance. Okay, what we know, the police is going 90 miles per hour. All right, Jennifer has a 3-minute head start. So who's been on the road the shortest amount of time? Well, that would be, oh, look out. If the officer overtakes her in 12 minutes, check that out. They tell us the time. So officer, 12 minutes. But wait a minute. Same predicament, right? Minutes. And then we've got hours. So we've got to do the same thing again. So scoot over and doodle. 12 out of 60 is what? Well, that reduces to 1/5. So this is 1/5 of an hour. Don't put down 12. Put down 1/5. That way they match. It does say that Jennifer had a 3-minute head start. Well, doesn't that mean that Jennifer had good old 15 minutes? So 15 out of 60 is going to be 1/4. So now we both have these in hours, which is great. The question does say, how fast is Jennifer traveling? Which is great because we don't have that box filled in, so there's our X. So when we multiply, I've got 90 times 1/5, which basically means 90 divided by 5. That would be 18. I can go ahead and do that. And then when I multiply these, I've got 1/4 X. Guys, you can write it as 1/4 X, or you can write it as X over 4. Whichever one floats your boat. It doesn't matter. It's the same basic premise as the other one. Some event happened, and the woman cut out, and the cop's trying to catch her. So the distances are going to be the same. So you're going to take the first distance, and you're going to set it equal to the second one, which was X over 4. Whenever you work that's just a proportion. Put that over 1. That's X equals, we just need 4 times 18. So Jennifer's going 72. And that's pretty sad if she's trying to get away from a crime. I drive faster than that. But make sure you make your units match is what we're getting down to. Okay, so the last thing is shared work. I'm going to try to do 2 versions. The basic version of shared work problems, they all set up the same way. It doesn't even matter if you have more than 2 people doing it. It typically says that you have 2 people or 2 companies or something trying to perform a job, and how long will it take if they work together. So the setup is always X over how much time they have plus X over how much time it takes the second group to do for one, the whole job. So whenever you read this problem here, you know, it is saying that they're wanting this job completed in 60 days. So one company estimates they can do it in 110. So that means we're going to put them down here, 110 days. Okay, and then the next group, they estimate they can do it in 140 days. So we're going to come up here, we're going to do 140. And it's one complete job. So we're going to see whether or not the answer ends up being greater than or less than 60. That's just going to answer this little weird question. If they hire both, are they going to be able to get the job done in time? So that's what we're looking for. But the way you work it is you need a common denominator. Well, you can do, if you wanted to, I mean, hopefully I'm hoping y'all see if there's zeros on the back of them, that means 10 has got to be a factor. And then you've got 11 here and you got 14 there. That's all three of your factors. So your common denominator needs to have 10, it needs to have 11, and it needs to have 14. You could go smaller, I'm sure you could, but I don't really want to sit here with a calculator trying to find what is the smallest common denominator of 110 and 140. If you wanted to just go crazy with it and multiply the two together and use this right here, it'll work. It'll work like a charm. So some of you were having real bad trouble, like how in the world did I get the 10 and 11 and 14? This right here is 11 times 10. This right here is 14 times 10. I made sure every factor was covered. That's all I was doing. So whenever I go through and I distribute what I'm going to get, I need to see which factors cancel. Well, on this one, the 11 and the 10 cancel, so I need the 14. So I have 14 times x. On this one, the 14 and the 10 cancel, so the 11 is what I need. And over here, I'm just going to have to multiply all that together. So 11 times, I hit the wrong button. 11 times 14 times 10. Yeah, just take a 0 off of this thing. And squish my 4 in there. Okay, so that's what I got. And if I add them together, I got 25x equals 1540. Divide it out. X equals, okay, so 1540 divided by 25 is 61.6. So that's how many days. Remember, we were doing days. If you wanted to answer the question, are they going to get it done in time? No, they will not. It's going to be late. Okay, so just as another one, again, a basic problem, x, and then we need the time. John installs it in 45 minutes, so let's just make sure everybody's minutes, because you do have to have the same unit. X over, and then Eric can do it in 30 minutes, and so that's going to be my 1, if they work together. So I need the number that both of them go into. Well, 15 is common, right? So if I, if I double 40, that's 90. I know 45 is going to go in there because it's times 2. 30 is going to go in there, and that's times 3. So 90 works well. So 45 goes in there, and we said that was 2. 30 goes in there, and that's 3. And then 90 times 1 is 90. So that's 5x equals 90. And when you divide it out, you get 18. And since everybody was minutes, what you really found is this is 18 minutes. Your unit stays the same. Now, there was one on the homework where it was a little bit different, and you had to structure it in a different way. So they actually told you somebody could do 1,000 shrimp in like 4 hours. Then somebody together they could do 1,000 shrimp in, I don't know, 3 hours. And the question was, how long would it take them to do so many shrimp? So if it was 500 shrimp, you put it up here. So it's always the number of items up here, and down here is time. And you can approach it the same way, multiply through by a common denominator. You should get your answer. Okay, hopefully I've got this under 14 minutes. So, thanks.